Alright, let's graph. So let's graph now with the natural base function. If we graph with our natural base function, we have the following generic function. A times e is our base, right? That's the natural base raised to the b times x minus h power plus k. Please keep in mind the parent function, once again, as always, just ignores h and k, which leaves you then with the following. Okay, it kind of helps at that point to note whether the function is going to be growth, decay, or neither, so you know you're graphing it correctly. And then just remember, you will want to shift accordingly. So I'm going to shift h units horizontally and k units vertically. Okay, so let's take a look at a couple of examples together. In example 4, we have the following graph. Negative 3 e to the power of 0.5x. Now notice this one doesn't have an h or a k value, or if you want to think of it, the h value is 0, the k value is 0, so we don't have to shift it at all. And because the a value is negative 3, this is neither growth or decay, right? This is neither. When we graph this, and I'll let you guys do this, only for graphing, I am okay to let e be approximately 3. Only for graphing, guys. Okay? Just because, you know, we're just kind of sketching a graph of what's going on here. If we wanted to be exact, we can use our calculator, and I'm fine with letting e be about 3. So, if we let e be about 3, we're sketching a graph of negative 3 times 3 to the 0.5x power. So if we were going to plug in some values, like 0, that would really be negative 3 times 3 to the 0 power, which means you just get negative 3 as an output. So if we were to plot that guy, you'll get that point right there. If we let x be 1, well, that would be negative 3 times 3 to the 0.5 times 1 power, which is just 0.5. So it's negative 3 times 3 to the 0.5, which we would need to use our calculator in order to figure out what e to the 0.5 is. And if I do negative 3 times 3 raised to the 0.5, you can check my work, but I believe you get about negative 5.2. Negative 5.2 if you type this into your calculator. So if we put that one down, that's going to be right about there. I'm going to plug in negative 1 and see what we get. If I plug in negative 1, that's going to be negative 3 times 3 to the negative 0.5 power. If you type this into your calculator, it's going to be negative 3 times 3 raised to the negative 0.5 power, and you get negative 1.73, or about negative 1.7. So negative 1, negative 1.7 is right about there. Now, this guy, since it's not shifted, the horizontal asymptote is still going to be the x-axis. We didn't shift that. And notice how these points are falling downwards. So I'm going to go like this, and it's going to keep on going. And as I move to the left, the graph is going to approach that horizontal asymptote. My domain is all reals. You can plug in any x value you please. Negatives, positives, zeros, okay. And the range, if you notice, all these y-coordinates are under the x-axis, which means all these y outputs are less than 0, and you'll never quite get to 0 as you move to the left. The hardest type of natural base functions I can give you are like in part B, where you'll notice there is some shifting. But before I look at all that mess, I want to only look at that parent function, which, because we're graphing, I'm okay with letting e be about 3. So really I'm graphing 3 to the 0.4 x. Okay, so if we were doing this, and if I plugged in 0, I get about 3, right? Or excuse me, not 3. 3 to the 0 power would be 1, wouldn't it? So that would make more sense. If I plug in 1, it's going to be 3, so let's write that down. If I plug in 1, it's going to be 3 to the 0.4, which is about, let's use the calculator, 3 to the 0.4, it's about 1.56, or about 1.6, let's say. So 1.6, if we plugged in -1, that's going to be 3 to the -0.4. If you do 3 raised to the -0.4, you're going to get about 0.6. So 0.6 there. Let's plot those 3 points. 0, 1, 0, 1, hello, and then 1.6. And then -1.6 is going to be about there. Now, again, if we didn't look at anything else and we only look at that parent function, our a value is 1, which is bigger than 0, and my b value is also greater than 0, which means this is going to be growth. This is an exponential growth function, and that matches how my points are going. They're going upwards. However, I don't want to just stop my problem right now. We have to shift things around. My h value in this problem is -1, and my k value is -2. And hopefully by now you know that means move everything to the left 1 and down 2. So let's do that. If we move it, and maybe I'll use a different color for my final function, if I go to the left 1 and down 1, 2, I'm going to have that guy be about there. This guy to the left 1 and down 2 is right here, and this guy to the left 1 and down 2 will be right there. Now remember, the horizontal asymptote, which was the x-axis, also got shifted to the left 1 and down 2, which now puts it at y is -2. So we're going to start close to that asymptote and rise up through those coordinates up and away like so. Domain, all real, and the range, y value is greater than -2. And I believe